Hey guys, and welcome to another installment of AIAA's UNSW Speaker Series, and where we hope to connect successful industry representatives to the student body. I would like to start to acknowledge the traditional custodians of the various lands in which we work today, and the Aboriginal and Torres Strait Islanders people participating in this meeting and webinar. I pay my respects to elders past, present, and emerging, and recognize and celebrate the diversity of Aboriginal peoples and their ongoing cultures and connections to the lands and waters of New South Wales. For those who don't know, my name is Viraj. I'm a first year aerospace engineering and physics student and also the Society's treasurer. Today, we're lucky enough to be joined by David Waterhouse, the CEO and co-founder of Hypersonix, an up-and-coming Australian aerospace company adamant of making spacecraft more eco-friendly. The best way I reckon to get into this is just to start with questions. So David, for you, what would you say? What type of student were you? And what's something that stands out to you now as something like a beneficial experience or things you wouldn't really recommend to students like us?
Okay, well, as a student, I guess I was the work hard, play hard kind. I've done a number of different degrees. So started off as doing engineering, electrical engineering at University of Queensland. I did an MBA at UTS and a Masters of Research at Macquarie. And as well, I had some time, I went to the International Space University to represent Australia back in 1989. And all of the different universities brought different things. So again, I guess it's important when you study to understand the basics, understand as well, not just the theory, but the practical application. And I guess that's the great thing about engineering. It's certainly a great foundation degree. And then being able to apply that to business, that side of things, and that's where the MBA helped. It gives you a language to communicate to business.
Yeah, definitely. No, thank you. Yeah, I think that's something we definitely do resonate with. That work hard, play hard. Especially now where with so much technology, we can actually, from home, we can start learning. We don't have to go to uni every day. So that is something that is very, I guess we understand a lot. Many of our students did express that they do struggle with keeping in check and not burning out. How would you say you dealt with coping with that stress and preserving your mental health?
Yeah, look, I was fortunate in that I always found engineering sort of felt natural. So it wasn't just hard work, it was really a voyage of discovery. And, I think if you're passionate about what you do, it's not really hard work. I think the trick is with burning out, again, I think keep a balance between study, sport, other recreations, and part of that, it's not all work, I guess. That's the secret. I think it's important to keep a healthy social life going as well. Like I say, with engineering, it was certainly a very difficult degree when I went through it. We had a lot of dropouts and people that carried through. So the great thing about having got through that process after engineering, real life was easy. They never worked quite as hard as they worked at university. So I think even though it's tough, my advice would be stay the course. It's worth it in the end.
Yeah, no, great. It definitely. We want to try and keep balances between, I guess, social and like recreational activities, you said, to definitely get that mind space. I can see through your LinkedIn that you did work at quite a few other companies prior to your current role. I guess my main question is, what's the main factor that got you like properly invested and interested into the space sector? And subsequently, is that what that you do start Hypersonix?
Okay. I've worked at a lot of places, partly because I'm old. I guess I always started in space. My thesis at university was all about encryption and how to use that on satellite networks. My supervising professor was the first chairman of OSSAT, as it was in the day. So really, right through my academic career and throughout my working career, I've always had an involvement with space. mainly on the satellite side of things. But, you know, when you're across one area of the sector, you tend to also pick up everything across the sector.
Yeah.
So my expertise is on the satellite side of things. I got far more involved. As part of launching satellites, you also have to understand the launch systems, the regulatory environment, and everything else that goes with that. As I mentioned, I was Australia's representative at the International Space University back in 1989. I was fortunate enough there to meet a whole range of astronauts. You know, Buzz Aldrin was there. Arthur C. Clarke was the chairman, and Peter Diamandis was the guy who set up the school. And that introduced me to a lot of interesting people from the space sector. It was important as Australian students to realize we have very good global standing in terms of our ranking. And, you know, we're equals with a lot of the best in the sector. From there, like I say, the commercial side of space really was the satellite side of business. That was the only option when I was going through there. If you have a look in the 90s, there was a big reduction in spend in the space sector. So I can show you timelines and programs from back in the late 80s where we should have been back on the moon for 20 years now and already have landed on Mars. Now we're playing catch up back to the same program, believe it or not. So, you know, space has evolved. And I think one of the main things about all of that, and we can come to this a little bit later, but new space is very different to old space. And I think there are a lot more opportunities, particularly for a country like Australia, than there was under the old space model.
And I definitely picked up a few good insights there, especially a lot of us, you know, kind of new to the space sector, kind of not too sure where the footing is, but no, definitely gave some clarity there. I gave my next question was it quite difficult, or what was the decision like to start Hypersonix, and what would you say the main purpose was about the company?
Okay, so I've done a number of startups before. This isn't my first startup, and again, that's sort of a natural progression. I started off with engineering, did business, ran some greenfield businesses for big companies, and then branched out on my own a couple of times. I think what it is, the opportunity for us, and I'm a big fan of disruption, so disruption innovation. And really that's where what you're doing is you're fundamentally changing the cost structure of a business. New space has presented that opportunity in the space sector. And that's where what's happened is there's just been a lack of competition, supernormal rents from existing players, and you've got an opportunity because the technology has reached a point where you can disrupt the existing technology. So the interesting thing about space is, you know, rockets, you go back to Goddard, so it's more than 100 years old, right? In that time, the basic design for rockets hasn't really changed. You've got solid, liquid, and your hybrids, but nothing really new. Okay, so you can have a look at you know, 80 years ago and have a look at where we are now, and the rocket designs aren't drastically different. So what's happening now with Hypersonix, this is a new way of flying. You know, this is the next step up. So we've gone from propeller planes to jet engines. We've had rockets, and this is sort of between rockets and jet engines. And this is an opportunity that has just come to the fore now. There are four factors that have come together to make this. One is we've got a huge market for the small sat side of things. So we're talking about 50,000 satellites being launched in the next 5 years, compared with a dozen to 24 satellites a year before that. So you can see there's huge market demand. Low Earth orbit, and low Earth orbit as opposed to geostationary. So it's a much lower orbit as opposed to 36,000 kilometers. So my technology is particularly well suited to that, and the fact we're talking about small sats. The other thing that's happened, the computing power. We used to do runs at UQ that would take weeks in terms of doing single simulations. Now we can run multiple simulations overnight, just using computers anyone can buy off the shelf, and the software to do that. We've seen green hydrogen, or the whole hydrogen economy piece, come together as well. We like hydrogen because it's a great fuel, huge ISP, much better than, you know, anything else out there. And it just so happens that on the back of this hydrogen economy, we're getting access to commercially available off-the-shelf materials that before you have to work in defense to get access to. So, all of these things have come together quite nicely. So I guess that's why. And then I think the final element, and this is particular to us, Michael and I went to university together. He did the aerospace side of engineering. I was on the satellite side, so I'm the customer side. He's the technology side. He'd reached the point at university where basically the technology had gone as far as we could go from a research point of view. We came together and, I understand the customer demand side. I understand how to start up and run a business. So we basically said, now's the right time to commercialize this technology.
Yeah.
Okay. Does that all make sense?
Yeah, no, definitely. Yeah, definitely gives a clear path of, how you got there in the end, which is very, very cool to hear. A bit more on that hydrogen. You did say you were using it. Can you tell us more about the benefits of using that as opposed to traditional solid fuel? Yeah.
All right. So, and again, this is my personal bias, so I'll make no apologies for it.
Yeah.
Look, solid rocket fuels have their uses. The great thing is it's a very stable thing. It's perfect for things like ICBMs where they just sit there. They're very reliable. You light them and they go. All right. The downside of solid rocket fuels is they're terrible for pollution. It's like burning plastic at the end of the day. So solids, good, reliable, great for storage, but terrible when it comes to the environment. And again, really, if I look at it with an engineering hat on, liquid hydrogen, liquid oxygen, it's about as good as you can get when you look at the rocket equation. And again, it's a bit tricky to deal with. I mean, liquid hydrogen is difficult. Liquid oxygen is really difficult, and you've got to be really careful with, but the engineering's there to do it. You've just got to be careful, know what you're doing. Hybrid, I'm not a big fan of. And the reason for that is you've got the nasty pollution with the solid, and you've got all the complexity of handling liquid oxygen. So you've got the worst of both worlds in a way. And again, it's better efficiency or better ISP than your solids, but still not as good as your liquids. Okay. What we're looking at doing, we're looking at using hydrogen. We don't need to worry about oxygen because we're air breathing. So think of us, we're like a jet engine, except run super fast, very high altitude. So that straight away simplifies what we've got to do. There's we've been able to piggyback on the high pressure hydrogen side of things. And really a lot of this development has been coming out of Europe and Japan and Korea. And what they're doing is they're getting high pressure hydrogen and using that for trucks, buses, that side of things. They're talking about 700 bar, so it's fairly high pressure. But again, they're available off the shelf. I don't need to design and build a tank. I can just literally go to the catalog and say, I'll have one of those. I just plug that in and then I can fly that. And it's really important, not so much for the cost of building the cylinder, but it's all the infrastructure that goes with it. So Toyota, for example, has got a refueler that can refuel that 700 bar tank in a couple of minutes.
Yeah.
Whereas before we did a project and we were using CSIRO to help us refuel the high pressure tank, it took 2.5 days.
Oh, wow. Yeah.
So having that infrastructure, and it's all the safety, the procedures, the systems, the processes, the certification in place, is a really good reason to use this off the shelf, commercially available stuff and repurpose it for space. So not only does it save cost, time, but also reduces risk. Okay. So we're using high pressure for some of our demonstrator vehicles. We're also looking at liquid hydrogen, and we'll be using liquid hydrogen for the orbiter. Again, there's very good progress in this on the commercial front. BMW had a 7 Series 10 years ago that was running on liquid hydrogen. And again, you're starting to see it not only in the automotive sector, but also the airline sector. There's a big push for using hydrogen there. And the great thing about burning hydrogen is the byproduct is water. So it's very green environmentally. The other nice thing is with green hydrogen, you can effectively produce it from water using green energy, such as solar or wind power. So you've effectively got the fuel being produced in a green way and no byproducts, no poisons and CO2s or other nasty stuff. Does that make sense?
Yeah, definitely laid out a few good points as to why, it's better that we're kind of shifting to like a more renewable, more eco-friendly sort of space sector, which is, I guess, what we love to hear.
Yeah,
We did say that on your website, your company is very good with promoting their eco-friendliness and showing that that is definitely something that we need from the space industry in the future. Um,
and
I'd say yeah. Sorry, continue.
I was just going to say, at the end of the day, it's just good engineering.
Yeah,
Yes, it's environmental and sustainable, but it's a great fuel.
yeah,
And one of Michael's points is, why would you throw away? Why throw away the whole rocket for one use?
yeah,
it's so wasteful. And again, the engineering required to reuse things. I'm not saying it's easy, but it's certainly doable, and it's certainly achievable today with the technology we've got. So.
yeah, definitely. And I guess my next question is, what was the biggest hurdle? I guess both on the business side and maybe something a bit on the engineering side as well, for your company.
Yeah, look, and again, I guess there's always challenges in this startup. I mean, the technological challenge for us, really the constant challenge for us at the moment is getting the materials. So because of the speeds we're flying at the altitude, we're talking about having materials that are good for 1300 degrees C to 1800 degrees C. So that's doable. There are composite materials out there and available today, but it's very early stage for that technology. So one of our big challenges is being able to use those materials in big enough sections and in a cost-effective manner. And that's really important for our reusability side of things. So I think that's probably the biggest technical challenge for us at the moment. And again, it's there, but it's something that we're still working hard on. The other challenge for us from a business point of view, there are a lot of people out there that do not believe hypersonics even works. So there's a lot of ignorance or lack of knowledge about the whole field, which is difficult. And it's almost, you have to, there's almost a religion about rockets versus everything else. And people who like rockets don't like anything else. So we're trying to we don't see it that way. We're happy to work with rockets. We like rockets. They're very useful for us. But rockets are good for some things. We are an air-breathing system. We have wings, so we have this thing called lift. So it's a different paradigm to your rocket equation. And getting people over that hurdle has been quite difficult. At the end of the day, what we're working towards is we're trying to make access to space not only green and sustainable, but just like catching a plane. That's our end goal.
Yeah.
And that is the way to get both costs down and performance up. So I guess that's where we're going.
Yeah. So I guess that's one of your goals as a company, I guess, making it more accessible to just the general public as well and getting them hyped up about it.
It's a huge resource, and it's providing access in a way that's going to make life on Earth a lot better. And space is one of the applications. The other application is airline travel. And again, airlines produce 2.5% of the world's CO2 at the moment. One Falcon 9 launch is roughly the equivalent CO2 of 100 transatlantic flights. So what we're trying to do is we're saying, hey, rather than use rockets to travel through the atmosphere, which is really inefficient, use us because we're fast, we're efficient, we're a great way to fly through the atmosphere, and apply us not just to space launch, but also have a look for airline travel. Because again, I use a lot less fuel. I'm a lot greener than a jet engine.
Yeah.
And I'm faster.
Yeah, definitely that's a benefit. Definitely, yeah, with some good points there. Telling us a bit more about where it's going in the future. Can you tell us a bit more about the Delta Velos and what's the main purpose and design of the mission?
Okay. So Delta Velos is a technology demonstrator, an MVP. And what we're doing there, that's a fully composite airframe design. It'll demonstrate the acceleration from Mach 5 to Mach 12. And also what we want to do is turn it around quickly. So basically land it, refuel it, fly it again. So it's that reusability and the speed performance that we're keen to demonstrate on it. And it's about a 2/3 scale model of Delta Velos orbiter. So the orbiter is the similar configuration. It's got liquid hydrogen fuel and the third stage in there. whereas delta VLOS is a two-stage system.
No, definitely good, and I guess we can kind of relate because especially in our student projects, we're starting to use a bit more and more composites, as you know, they do get slightly more affordable. So it is great to kind of get to that clarification that maybe it is the right direction. There's quite a few benefits, and yeah.
Yeah, I think ultimately it will be. What we're finding is the composites are still very expensive. They're getting more affordable and there's more options out there. Australia is a number of years behind the rest of the world from what we're seeing when it comes to composites, which is unfortunate. But having said that, you've got the other options which are around the high temperature alloys. And again, there's some very good work we're doing here in Australia with the high temperature alloys as well. And they tend to be probably a fifth the cost. So it's for us, it's one of the things we're experimenting with, having a look at composites and the high temperature alloys.
That's actually quite cool. We also saw that I guess you have a engine called Spartan. And you said it's quite reusable, and obviously you did mention before it's hydrogen, and guess that's kind of why it's fuel efficient. Where do you see the future of this project, and do you think you can apply it to any other situations where people would have thought it's not entirely aerospace and aeronautical, but are there any other uses for technology like this?
Yeah, so Spartan's the scramjet engine. It's what we call a fixed geometry engine. There's a number of different scramjet designs out there, but we're focusing on fixed geometry. And the advantage with that is there's no moving parts. And that in turn it makes it very reliable, makes it possible to 3D print. So the production cost is quite low as well. In terms of applications, again, you can think of an application, anything where you use a jet engine, you could potentially use it to scramjet. So one of the projects we've got with Boeing is we're looking at a hypersonic airliner, and we're working with Boeing. We'll do the airframe design. They're looking at using our scramjet engine for that.
Yeah, that's quite good to see that, you know, even the companies, you know, they can work together and like make that collaborate, which I guess is a good step forward for the space industry, especially in Australia where you like pick each other up. So yeah, that's great. I guess now we did have a few questions. What sort of career opportunities for our space enthusiasts do you guys maybe have at Hypersonix, and is there any set way to apply, and what type of skills and qualities would you look for most, I'd say, in an engineer, because that would be more our audience right now.
Okay. Well, look, I think in any sort of career, when you start off young, I think it's very important to specialize. So vertical specialization is quite important. So in terms of the areas we're looking at, so obviously we're doing a lot of work on the hydrogen side of things. We're doing work on composites, high temperature alloys. We're doing structural engineering side. And those are, well, and the hypersonics itself, of course, not to mention, we also are doing work with rocket companies as well in terms of the stage 1 and stage 3 systems. So one of those verticals, be really good at it. What happened in my career, as an example, I started off with my particular specialization and then went from that to the project management side of things. And project management's a very useful tool. It really helps in getting an understanding of systems. So while you can have a particular vertical specialization where you provide both the technical and the project input, it's important to understand how these systems work together, because systems integration is really one of the biggest challenges when it comes to the aerospace sector. And then finally, you know, if you follow the same path I did, some sort of business degree. And really, the end of the day, it's another sort of language, but being able to understand how the business works also enables you to understand how to apply the technology to make the business better. And that really in turn leads to disruption. You know, how can a small company like us effectively provide a global service and sell to a global market? You know, 20 years ago, it just wouldn't have been possible. But today, with the way the technology is going, with the new space environment, there are real opportunities that way. And that's where small companies can disrupt these big established companies.
Yeah, no, that's very, very good to hear that, after uni, just stick with it, I guess. Don't get to sidetrack, I guess if you have a goal, just like go for it. That's what
Yeah.
obviously, just even though it may not seem like there's a lot of jobs, I guess later down the line, you will find something, which is, I guess, a lot of, even for me personally, even though I'm already only first year, it is definitely good to have that kind of confidence, backed by industry leaders that, it's not a pipe dream and it's more of, there's like a realistic aspect as well at the end.
Yeah, and I think the thing to remember, we're part of a global community, so, and again, if you look at my career, I've worked all around the world. It's easy to, well, I won't say it's easy, but it's certainly possible to do now. And, if you're in the right field, if you're passionate about what you do, the job will find you, and the great thing about the space sector, you're seeing an explosion in investment and the number of opportunities that go with that. And I think for the first time, we're starting to see people who'd gone over to Europe and the US to work over there from Australia are now coming back to Australia as the market opportunities here rise. So,
Yeah, no, I think that last one was very good. I guess, speaking to a couple of people from that did aerospace engineering, aeronautical engineering a couple of years ago, their plan was always do the degree here, go to America. But honestly, that's probably like, it's not the most ideal situation. It's like being born and raised here. We definitely want to see it. Might be a little patriotic. We definitely want to see the results here rather than in a foreign country. So yeah, it is definitely good that, I guess, companies like yourselves are paving a future for us, which we are very thankful for. I guess maybe a bit of a lighter question now. What is your favorite thing about the Hypersonix team?
we've got a great high energy young team. Well, some young, some old. No, but I think we're all passionate about what we do. We're here to make a difference, and we're going to do that. And we've got some grey hairs like myself and some very young people as well. And together we're having fun doing what we're doing what we love to do. So, that's what I like about it most. And I think as well, we're doing, there've been a lot of naysayers out there, and I think we've proven them wrong. We're really starting to deliver the goods. So that's what it's all about, I think.
Yeah, no, definitely. That is, yeah, we do love to see that. I guess maybe a bit broader on the space industry, like you were saying. Where do you see the Australian space industry, aerospace industry, like in the next 5 to 10 years? And what do you think would be something you would like to see implemented, within that time frame?
Well, and I think I've said this before, I'm a big believer in the new space business model. And that's partly because when I had a look at the space sector back late 80s, early 90s, I did a report for the government at the time. And I think that report's still true today. The Australian market is not big enough to sustain a space sector by itself. The only way to have a sustainable space market is for us to be globally competitive. So we have to provide services and technology that are as good, if not better, than what people can buy or use anywhere else in the world. So that's number one. So what I would like to see in terms of the Australian sector, and the nice thing is we've got no baggage here, no history, other than the satellite side of things. When it comes to space launch and that side of things, actually, when it comes to satellite production, we have no history here. So the good thing about that is we've got a clean slate. We can use modern cost structures to become globally competitive. We have a certain natural geographic advantage. We've got the largest east-west in the Southern Hemisphere, and that has its advantages in terms of Earth observation, for example, because it means we can download and dump data from these satellites that travel around the world. We've got the world's largest inland test range. If you have a look in terms of the ability to fly over land, that's very important for launch system development because it means you can recover the vehicle or what's left of it, as opposed to flying it over the ocean where it just disappears. So, we've got a few advantages here. We've got great coastline. We've got lots of different launch angles and launch opportunities as well. But for us to be globally competitive, we have to be better at it. We have to be cheaper. We have to be quicker. And people forget about that last thing. Cadence is the most important thing when it comes to satellite launch. So we need to have, and that's not just a technology issue, that's a regulatory issue and a business issue as well. So we need to be able to launch things really, really fast. If you have a look at other companies, Rocket Lab is trying to get to the point where they can do one launch a week, I think. The moment they're stuck at about one every 2 weeks. But really what you need this to be like is like an airline, catching a plane from Sydney to Melbourne or something. You can't have these restrictions in place. And this is one of the things that I don't think people have really grasped yet in Australia. It's as much about the regulatory, the insurance, the commercial environment as it is about the technology. And if we can create that business environment where it facilitates that high cadence and low cost, we will be globally competitive. Okay. Yeah. And that's really what I want to see. That's the opportunity for Australia. And this is a generational opportunity. You know, we're not going to get this chance again in the next 50 years. So we need to make the most of it now.
Yeah, I can definitely vouch for the students here. We're very passionate about the space, and, you know, if there's a challenge, we're more than happy to try solve it, try help with it. As I guess that's better than there being no challenge. Yeah, and I did hear you mention a couple of times this old space and new space. I guess like kind of going back to that for people that aren't too familiar with the jargon. What's like the main difference between those two, apart from, I guess, like the main time difference, I guess, I'm guessing? Like what's the main...
So yeah, and for me it's so let me explain what old space was. And old space had its role, you know, and basically old space was sovereign silos that were monopoly providers for countries. So basically government paid for it, government used it. Yep. Okay. And your classic case is NASA or ESA. So basically there was a single company doing launches out of America at the time, and it was NASA or defense. All right. So it's all government owned, government controlled, government paid for. And if you had a look at that, there was no competition, no real competition anyway. And if you want a price, you take $1, multiply it by 100, and then, you know. Yeah. So, and the thing is as well, it was slightly even more ubiquitous than that, because what it meant is you had to use a US satellite launched on a US rocket launched from the US, for example. Okay. Yeah. And that really restricted the growth in the technology, because when the government decided they didn't want to spend money on space, there was nothing else out there. So going back to Peter Diamandis, who I mentioned early on, he launched back in 1989 something called the X Prize. And the X Prize was for the first commercial launch of a rocket, or something went to space, I should say. And in the end, the company that won that, I think it was Composites, that was bought by Virgin. Okay, so Virgin Galactic is what came out of that. But that opened the whole door to commercial space activity. Now, fast forward to where we are today. So what's new space today? New space is when I build a rocket, I can take parts and components from all around the world. Okay, I don't have to launch it out of America. I can buy components. If you have a look, what a lot of the commercial launch services are now using, and this applies for launch services and satellites, they're actually using US automotive standard parts rather than space parts. And they're actually finding they get the same availability. And you think about it, from an engineering point of view, if I'm making tens of millions of parts for the auto sector, it's probably going to be more reliable than a part that I make in a lab and I make 10 of them. And that's simply because, you know, you've got that advantage of scale. And of course, the cost is a fraction of the cost as well. All of a sudden, as a commercial guy, I say I've got a satellite, I can choose which company I launch my satellite from, which company I use to launch, which country I launch from, and where I put, you know, the regulatory environment I want for my satellite as well. So instead of this vertically integrated stack, you've got components, systems, and regulatory provided from all around the world. And so you've got global competition now and a broader access to the services and, you know, to the services and the technology. I guess that's what I'm saying. Does that sort of make sense? So
yeah, I think it's a lot clearer.
Yeah, it's moving from a monopoly environment to a competitive environment. That's really what it is. And it also means the government isn't driving it anymore. It's actually industry. And if you have a look in the space sector, private sector investment, space sector overtook government 3 years ago. So that's the trend, and that trend is continuing now.
Yeah, and I think a good result of that is people that aren't even that like technical are getting more and more interested in space. I know definitely for a fact, for example, some of my family members, they like now tell me whenever they see a launch on like their social media, and they ask a few questions, and I do answer them to the best of my ability. But yeah, it's definitely good to see that it is still a good dream for us. And I
Yeah.
guess now we'll move on to some student questions that we asked. Um, let's say one of the questions is, who is your biggest inspiration? It doesn't have to be an engineer, just in general. What's someone that really inspired you?
Well, I can think of two. So Clayton Christensen, who is the guy who's basically all about disruptive innovation. And that's how to use technology to make the marketplace better for people. That's, if I'm going to summarize. So that's really important. And if I look from an engineering point of view, Kelly Johnson. So he was the engineer who designed the SR-71 Blackbird, as well as P-38 Lightning and a whole streak of others. And he is just inspirational in terms of what he was able to do with the slide rule and pencil compared with what we do today. And it's just amazing. It shows how one person can literally shape a company and shape a sector. So, those are two global inspirations. I think as well at university, Michael and I were very fortunate. We had a number of really cool professors. Like I say, my professor, Professor Gunn. Michael's professor was Professor Ray Stalker, who was the guy who basically invented the hypersonic shock tunnel, and which has led to Australia leading the way in hypersonic technology. So, I think when it comes to inspiration, think local, think global as well.
Yeah,
We're part of a
definitely.
community. So
Yeah, no, that is great, and it is good to see that there's different mentors, and obviously there's both aspects of it. Yeah, which is great. I'd say my next question is where does Hypersonic currently do the test launches, and where do you guys do my bulk of your like experimental stuff?
okay, so two separate things. So we haven't launched yet. We were part of a program early on called the Hi-Fi program, which is done out of Woomera with Defence, and that's
Oh
where
yeah.
Michael Scramjet first flew. Most of our research at the moment is done up in Queensland. So the University of Queensland has a hypersonic shock tunnel called T4, and we've used that for doing our hypersonic testing. We're doing fuel system tests. So for testing, what you do when you're testing a hydrogen fuel system is you start off with nitrogen. And we've had a test lab run of all of that to make sure nothing leaks and everything works the way it's supposed to. And again, we're doing that up a lab up in Queensland. In terms of our test launches, we're in negotiations now with a number of different launch providers. And again, we see our opportunity as global. We're commercial, not defense. So we're looking at commercial launch sites. So in Australia, we're looking at Southern Launch as a potential site. In Europe, we're looking at Andoya, which is out of Norway, and in the US out of Wallops, which is East Coast. And we've got different, the launch site depends on your booster provider, really, because they're the ones who've got to do things like the safety templates. So when we have the launch provider sorted out, that will in turn inform which launch site we use.
Yep, no, definitely. That was some good information there. Yeah. And guess my next question that quite a few people have asked is, let's say down the future they want to work with hypersonics, maybe try to get a job. What is a main way they can apply, and what's something that maybe the people that do the hiring, or maybe yourself, value when you look at maybe a graduate or someone that's only a couple of years out of uni and kind of fresh to the whole market?
So in terms of applications, we mainly will advertise for roles. We tend to use social media, LinkedIn or Glassdoor. In terms of the roles we're looking, what I'm looking for is I mean, academic is important, work ethic, but really it's attitude is a big factor for us, because at the end of the day, great thing, universities give you a baseline, a framework, but you're really going to learn when you're on the job. And I think, the importance of the academic background is it gives you the tools on which to learn better and faster, is the way I look at it. So that's what we're after. And again, we're looking at the same sort of systems as you get for any launch system. So it's everything from electronics, GNC, materials, boosters, fuel, composites, structural, etc.
Yeah. So yeah, definitely. Thank you for a few hard and soft skills that we should probably keep in mind. That is great. And yeah, that is yeah. I guess it's more or less quite clear now what many people look for, and I guess it's better now that there's a lot more variety of aerospace jobs and of aeronautical jobs rather than just that being the one title.
Yeah.
Yeah, it's a bit of a different question now. Do you think Australia will be able to have their own astronauts or yeah, like deep space pilots, those
Yeah.
type of
Well,
things?
look, we've had two astronauts already. So Paul Scully Powers and Andy Thomas, and we've got another astronaut who's due to go up shortly, Dr. Chris Boschhusen, I think. I think he's going up on the Amazon on Bezos Blue Origin. Yeah.
Yeah,
So you know, I think what you're going to find is we will have more and more astronauts out there. Certainly, space tourists. Okay, that's for everyone. But really, what it's going to depend on is, you know, the astronauts I know, they've all had a specific skill set. It's been, you know, it's not a free ride. You're going up there to do work. And so really it's about the skill set that they need or they will need. And that's really why you get the ride to space. It's interesting. I think the FAA recently changed the definition of space to basically exclude the tourists. But you know, and if you have a look what's happening, the big expenditure is going to be coming on the Moon project and the Mars project. I suspect that the way Musk is going, you know, he may hit Mars not long after we get back to the moon, which is wonderful.
yeah,
And I think the sort of skills you're going to need there, it's all going to be about really, you know, if you have a look at the project, the TV have a look at the movie The Martian. That's
yeah,
a pretty good example of the broad range of skill set you're going to need. Now, historically, astronauts have they've had a speciality, but a whole range of other skills as well. So you have to be a bit of a generalist, but also a specialist. We'll see what happens as the astronaut community grows. But I suspect you're going to find it's the specialist skills that are going to be the main driver.
yeah. No, definitely. Yeah, definitely do. Yeah, especially that Martian. But like, I guess there's a lot more realistic pictures of like movies coming out and TV series coming out that actually isn't as fictional as it may seem. You know, giving us a good like insight, even though it is a long way away. It is quite a bit of science fiction, but it is definitely cool to say that you know one day, that could just be a normality and not really like something that is that out of reach.
Yeah.
And yeah, I guess one final question is, all right, picture this, you know, you see your test launch going up, it's successful, everyone's congratulating you, you go home or on the drive back, what's the meal you have? You know, what's that one celebratory meal you have? Like, what's the food and what's the drink with that?
Oh, gee, that's a tough one. I'd probably be a nice big steak with a glass of red, or I'm not sure. I'm sure we'll be celebrating anyway into the early hours of the morning. I'm not sure we'll have much time for food. Um, but yeah, look, we'll see. And really, that first test launch is this. It's just the end of the beginning, if you know what I mean.
Yeah,
And it's an important stepping stone. But that's really when the work will begin. You know, that's, you know, as daunting and challenging as that first launch is, once you reach that, then the real work starts.
yeah,
And
definitely.
you know, I think that's important. Always plan ahead.
Okay, yeah, yeah, definitely. We'll keep that in mind. Um, and I guess before you leave, do you have any wisdom on part of our current aerospace students and our aeronautical students that really, I guess, they just, I guess, we're in a kind of position where we're happy, we're kind of nervous about what comes in the future. We're very hopeful though. But do you have any like wisdom that you can maybe impart on us, something to just keep us in check, I guess?
Well, look, my only advice is, you know, do what you love. You know, if you're passionate about something, everything else will take care of itself. And I think the other thing is to remember it's a global community out there. Don't limit your horizons to just what's happening here in Australia. It's important to keep that perspective. We're we're an island, but we're not an island, if you know what I mean, when it comes to the aerospace sector. And there are huge opportunities now. There are a lot of great universities around the world. There's a lot of great industry opportunities as well. Yes, Australia, of course, is our favorite. I'm not saying otherwise. But there's also opportunities overseas as well. So I think have a look, stay plugged in, remember to follow what's happening in the global community, not just the Australian community. Okay. There's some areas we do really well at, there's other areas we're a little behind. So just keep that global view. I think that's really important.
We did just get a couple last minute questions here. How do you ensure productivity in the workplace and make sure that everyone's like as committed and as enthusiastic as possible?
Okay, well, partly that gets back to our recruitment process. We grab people that love what they're doing, so I don't need to push them hard. I don't tell them what time they have to get into the office and what time they have to leave. They have a project and they're working, doing the stuff they love. So, and I think that's important. We have a very collaborative and supportive work environment. At least that's what we try and foster. So, you know, I think the other important thing is we have a work environment where it's okay to fail. We don't mind if people make mistakes. We learn from that and then we move on, and that informs our future work. So it's that high energy, collaborative sort of openness, I guess, we're trying to push. We're all driven with what we're trying to do, and I think we believe what we're trying to do, believe in what we're trying to do and why we're trying to do it. So that's what it's all about.
Yeah, no, definitely. I guess we got one more last minute question. I guess this one was a bit more specific about the Delta Velis orbiter, which I guess is that big project that you know, from, as you said, from Mark 5 to 12, and it's a whole intricate system. What's something that you'd say was the main driving force of you, I guess you and your other co-founder kind of designing it, and what's like a hole in the market that it clearly caters to?
Well, like I say, we're demonstrating the use of scramjets for new applications. And I think for us, because it's a new application, there are all sorts of new product opportunities that people haven't envisaged before. So you think about it, we're going away from single-use throwaway to something where we're reusing it hundreds of times. We've got different launch profiles, we've got different speeds, different challenges to do with traveling through the atmosphere at those speeds. So, you know, all of these factors come together. Again, Michael's the aerospace engineering expert. I do a bit of the systems and the electronic stuff and the customer side. So, you know, it's a team effort in pulling it all together.
Yeah, well, definitely. And I guess sorry, I know I said a lot of final questions. Julius, the last one. Are there any opportunities for engineering students to do like a thesis and partner with Hypersonix?
Yeah, look, we have a number of interns. We're a small business, so but at any given point in time, I think we've got 2 interns at the moment. Michael tends to only take PhD students these days. And that's simply because the hypersonic side of things is not a graduate sort of technology. But yeah, it's open, and we have close association with a number of universities at the moment, and we will continue that association as the business grows, both in Sydney and in Brisbane.
Yeah, no, that is great to hear. Hopefully down the line, some of our students that are watching now can maybe have the opportunity to work with Hypersonix. I guess so. That's for everyone. Thank you for joining us for another episode of the AIAA UNSW Speaker Series. As we near the end of week 9, we just want to say good luck to everyone in upcoming assignments and exams. And thank you so much for your time today, David. If some of our members want to contact you, do they have any? Is there anything you prefer they contact you through if they have any further questions?
Yeah, our website, first of all, it's got a great video, so watch that. It explains what we're doing pretty well. But also, there's contact details there as well, and we get through those. We check them quite regularly. Okay.
And okay, definitely. So, just the website, so it should be fine. Yeah, no worries. And yeah, we saw that Hypersonix will be participating in the AIAA Ascend event next week, where I think your co-founder and the CTO Michael Smart will be giving a
Yeah,
talk. So I think that's something for our students. Maybe if they want a bit more information, they can definitely look out for it.
that's going to be a
And
lot more technical. Yeah.
yeah, and I think maybe that's maybe what we need now. It's good. So yeah, I guess thank you for that. Now, is there anything you wanted to say before you left? Anything you wanted to tell us or ask?
Well, just good luck with your exams and everything else, your exams and assignments. And hope you guys all do well.
Yeah, thank you.